In this video, we're going to talk about matrix inverses, and we're not going to so much talk about how to calculate the inverse. That will be for a later video, but we're just going to investigate what is the inverse of a matrix. And so as we jump to this, I want to have this little definition down. I think I've covered it in a previous video, but I want to have it fresh in our mind. In order to know where we're going today, we need to know what the identity matrix is, and that would be a square matrix in which the main diagonal elements are all 1 and the other elements are 0. So identity matrix will always be a square matrix, and here we have the 1s with zeros in the other places. Here for a 3 by 3, this is also this is a 3 by 3 identity, so it has all 1s for the diagonal and the zeros elsewhere. You can have a 4 by 4 identity matrix, so on and so forth. So maybe write that down, store it in your memory bank, because you need that for where we're going. And so here is what we have about inverses, and the inverses have several purposes, but one of the main purposes of the inverse of a matrix is that it will help us find solutions to a system of equations. And so we're not going to go into that right now, but just kind of know that this idea of inverses is helpful, and we'll kind of investigate how to do those things more later. But for now, let's just kind of learn about this one property of an inverse. And here's what it is. The inverse, and we use this notation for an inverse, almost like with functions how we do an inverse. But the inverse of a matrix is a matrix such that a matrix times its inverse is equal to the inverse times its matrix. In either way, in either direction, when you multiply those, you're going to get the identity as your product. And this is important in case we've forgotten, because if I have two matrices AB, we learned in previous videos that AB is not equal to BA. The multiplication of matrices is not commutative. In other words, it's not like regular numbers where I can multiply 3 times 4 and get the same thing 4 times 3. That does not work with matrices, okay? So that's important here. So with these inverses, it is commutative. A times A inverse is equal to A inverse times A, but no matter what, whenever we multiply those, we should get the identity. Think of them the same way you think of multiplicative inverses. If I multiply 3 times 1/3, I get 1 because those are multiplicative inverses. Okay? If I multiply 1/8 times 8, I get 1 because those are multiplicative inverses. That's kind of like what these matrix inverses are. And so, just in case you don't believe me, what I'd like to spend the rest of this video doing is I've given you a matrix and its inverse, and let's just see what happens. Let's see if this is true. Let's test it out for these given matrices. So first, let's multiply A times its inverse, and then let's multiply the inverse times the original matrix. And let's see what we get in both situations. All right, so I'm going to multiply this row times this column, and so we have 4 times -2 plus 3 times 3. And then I'm going to multiply it times this column. So, I'm running out of room. Okay, so I'm just going to run out of space there. And then let's multiply our second row times our 2 columns. So let's do 3 times -2 plus 2 times 3. And then let's do 3 times 3 plus 2 times -4. And let's just see what we get when we go. Because according to our property, when I multiply matrix times inverse, I should get the identity matrix. And let's see what happens. So I'm going to kind of copy down below here what our product is. It looks like we have -8 plus 9. Here it looks like we have 12 plus -12. Here we have -6 plus 6. And here we have 9 plus -8. And so you can see that this matrix is in fact the inverse for this matrix, because whenever I multiply them, I get the identity. Okay? So I'm going to erase this. I kind of gotten into my space here, but let's try the same thing in the other direction. Let's see if I multiply an inverse times the matrix in the other order. Let's see if it still works in that case. Okay, so I'm going to multiply my first row times the first column. Once again, I'm kind of assuming we have a background knowledge in this video of how to multiply matrices. If you don't, maybe watch that video a few times first. And then I'm going to multiply my first row times my second column, and that would be -2 times 3 plus 3 times 2. And let's go to the bottom row, and I'll switch up colors. So now we're going to do my second row times my first column, and I'm going to have 3 times 4 plus -4 times 3. And then my last element will be the second row in the dot product of the second column. So then we have 3 times 3 plus Negative 4 times 2. Forgive me for running out of space. I know that's getting super messy. But we should have enough to be able to figure out what the product is. And if I do the math on it real quick, we have negative 8 plus 9. We have negative 6 plus 6. We have 12 plus negative 12. And we have 9 plus negative 8. So we can see, we've really just spent this video verifying this property up here, that when you multiply a matrix times the inverse, you get an identity, and that whenever you multiply by those inverses, it is commutative, whereas most matrix multiplication is not commutative. In future videos, we're going to look at more about how these inverses are used, but for now, I just want you to know what an inverse is.